Hello all and welcome to another math lecture. This is Dr. Lennon and we'll be going through the Module 3 sections 1.1 to 1.3. I just had like a minor disaster. I tried recording all this and I had some sound issues. So this time I got everything fixed, so I should sound a lot more clear. And let's get ready to talk about math, I guess. Alright, so we're talking about linear functions, and first to deal with those we're going to have to talk about plotting points on a plane. I'm sure most people have seen this before. Horizontal axis is the x-axis, vertical axis is the y-axis, and these ordered pairs come at you in x-y order. So whenever you see points, they're just telling you how far to go in the x direction, how far to go in the y direction. Positive is right in the x direction, and negative is left. And for the y direction, positive is up and negative is down. So if we want to plot 1, 4, we go 1 in the x direction, 4 in the y direction, and we find our point right here. So let's label that A. B, we have negative 2, 2 steps to the left, and positive 3, 3 steps up. So that's B. C, we have negative 3, negative 5. I didn't quite come down far enough, so let's make another point, negative 3, negative 5. We have point C. And D, negative 4, 0. It's this point right here, so that's D. Let's notice that a point on the x-axis has to have a y value that has value 0. And a point on the x-axis similarly, a point on the y-axis similarly must have x value equal to 0. So that leads into our next question. If we come down, true or false, if a point is on the y-axis, its x-coordinate must be 0. Well, that's got to be true. It can have no horizontal displacement, so the x value has to be 0. Okay, let's move on down. Whenever you have something like y equals x squared plus minus 2, a formula, what you want to do is just do x squared minus 2. I forgot to erase that 2 from last time when I tried this. And make a table of values. So here they tell you to use the values negative 3 to 3. In general, those are good choices for simple functions, but if the functions are a little more exotic, you may need to use different points. And then come over here to the formula and plug them in. So negative 3 squared minus 2 is going to be 9 minus 2. That gives us 7. Negative 2 squared minus 2 is going to give us 4 minus 2, which is 2. Negative 1 squared minus 2 is positive 1 minus 2 is negative 1. 0 squared minus 2 gives us negative 2. And then if you notice, if you square positive 3, you get 9. Square positive 2, you get 4. And square positive 1, you get 1. So these values will all just repeat in the opposite order. So we'll get negative 1, negative 2, negative 1, positive 2, excuse me, and positive 7. See you later. Alright, let's get back to it. So, positive 2 goes here, and positive 7 goes here. And we can graph these wonderful points and connect them up with a smooth curve to show the pattern of the function. Alright, so notice the y values go from negative 2 all the way up to 7. So we put those values. Sometimes I like to just write the ones on the ends to remind me, and then you can kind of see what the tick marks represent. And the x values, we're just going from positive 3 to negative 3. So nothing too exciting there. Negative 3, positive 7 at this point. Negative 2, positive 2 at this point. Negative 1, this point. 0, negative 2 is here. And then we get the symmetric points. Alright, now we try and connect these with some sort of smooth curve. I'm doing the best I can. And the age-old use of graph paper is still helpful here if you are not super neat. Okay. Very similar exercise coming up. So let's make a table of values, x, y. This one's actually pretty easy because the x values we're going to plug in still negative 3 to positive 3. But the formula is a little easier because we have 2 times absolute value of x. So we just do twice the positive value. So this will be 6, this will be 4, 2 times positive 1 is 2, 0, 2, 4, and 6. So we use those points to make another graph. And this one is basically just going to be a V that starts at the origin 0, 0. So let's make our x values, and our y values are all positive, so I just need to make sure I go up. 1, 2, 3, 4, 3, 4, 5, 6. Alright, I already got them. So x, y, got enough, negative 3, positive 6, all the way up top. Negative 2, 4, right here. Negative 1, 2, right here. And then again, this graph happens to be symmetrical. We will learn out later that this is the concept of an even function. So that's half your graph. Here's the other half. It's like the line y equals x with the other half kind of flipped about the x-axis as a mirror, left of the y-axis. Alright, this viewing rectangle, what it's really telling you, so when we look at the values, negative 20, 80, 10 by negative 30, 70, 10, it's telling you the x min, the x max, and the step sizes in the x direction. So if we want to draw how big this picture would be, basically we start at negative 20, and then we go to negative 10, because we're jumping at intervals of 10, 0, 10, 20, 30, 40. I might not have made enough room on the page. We'll see. 50, 60. We'll put the last two just a little close together. I know that's not great, but 80. So that's basically what the picture looks like in the y direction. In the x direction. How about the y direction? So that's the x value. The y direction says negative 30 to 70, again with step sizes of 10. So we'd come down here, we'd have negative 10, negative 20, negative 30, and then when we go to the top, we got to count by 10s to 70. 10, 20, 30, 40, 50, 60, and 70 all the way at the top of my y-axis. So that's all they're telling you with viewing angle or window, and that comes up if you use your calculator. If you hit the window button on any graphing calculator, it'll ask for x min, x max, and then instead of x, it won't say x step, it'll say delta x, so that would be your step size on the x-axis, and delta y would be the step size on the y-axis. So this is like the step size. The Greek letter delta, lowercase delta, is used to indicate change. Or maybe that's uppercase delta. I said lowercase. So uppercase delta is a triangle. Lowercase delta looks like this. That's lowercase delta. So this is uppercase. Okay, x and y intercepts. Basically, x-intercepts are just where the graph crosses the x-axis. So if you look at your picture on 4a right here, we can see that the x-intercept is happening right here. So what is the x-intercept? The x-intercept, remember that is an ordered pair. So that is going to be the value 2, 0. Notice that the y-coordinate is 0. That is always true for an x-intercept. How about the y-intercept? Well, negative 1, negative 2, negative 3, negative 4. This is 0, negative 4. So on a y-intercept, the x-coordinate will always be 0. So if you have an algebraic type equation, if you plug in x equals 0, you can find the y-intercept, and if you plug in y equals 0, you can find the x-intercept. Okay, so again, identifying the x and y-intercepts. Notice that our picture here does not have a y-intercept, doesn't touch the y-axis, so y-intercepts, we can just write none. But it does have an x-intercept. It crosses the x-axis right there at negative 1, 0. Pretty interesting stuff. All right, this problem was giving a lot of people fits on the homework, so you may want to pay a little bit of attention here. We've basically got two graphs, and we've got a formula that identifies the percentage of high school students, high school seniors that are using marijuana in the U.S. Also alcohol, but I think they may just be looking... Okay, notice in the formula, too, the way we describe N is years after 1980. So if you wanted to plug into this formula to figure out the marijuana use in 1990, you'd have to just plug in 10, because 1990 is 10 years after 1980. Okay, so let's come on down here and say, use the formula to determine the percentage of seniors who used marijuana in 2005. So let's remind ourselves what the formula is. M equals negative 0.3 n plus 27. So let's write that down. M equals negative 0.3 n plus 27. So that should be a 3. I know it looks awful. Maybe I'll erase it. I will. It's happening. Goodbye, ugly 3. Alright, so here's a neat 3. There we go. Yeah, let's make sure. Negative 0.3 plus 27. N is years after 1980. So this 2005 number corresponds to N equals 25, because 2005 minus 1980 equals 25. So we want to plug in 25 for N. Okay, so negative 0.3 times 25, I'm pretty sure that is going to be equal to negative 7.5 plus 27. So that gives us 19.5. Yeah, and remember that's a percentage, so it's telling us in 2005, 19.5% of high school seniors smoke that marijuana. Kind of a funny example. Alright, use the line graph to determine the percentage of seniors who are using marijuana in 2005. I guess it doesn't necessarily say that they smoke it, right? They might be doing other stuff with it, like maybe they just like the way it looks and they plant it in a pot. Alright, I'm getting a little out of control here. 2005, well, it looks like it's right at 20%. I would say 20, so it's pretty darn close. So I would estimate, I would say 20% here. So it looks like 20%. So let's look at the formula. Does it overestimate or underestimate the percentage of seniors who used marijuana in 2005? Well, since the formula is 19.5, that's less than 20. So we're going to say it underestimates. Gosh, I'm writing a little bit sloppy today. So let's say it underestimates by 0.5%. There you go. And that's it. Check it out. Underestimates by 0.5%. We got the answer right. Alright, on to 1.2, linear equations and rational equations. These are actually pretty easy, so we'll just move through them. Basically, it's the age-old technique. You can add or multiply or subtract or divide the same thing to both sides, and we preserve the equation. So this one, we want to start by just adding 3 to both sides, and we'll get 6x equals 66. And divide by 6, and we get our wonderful answer of x equals 11. Next one, solve and check, just distribute to get rid of all those parentheses, so 3x minus 3 minus x plus 7, negatives get distributed too. Combine our like terms, so we're going to have 2x plus 4 on this side, and subtract 4 to move that over here. So we have 12 equals 2x. Now divide by 2, and we get our answer, x equals 6. Alright, let's look at this next one. We have a bunch of fractions. So normally the best policy for equations with fractions is just eliminate them on the first step. It's a nice trick we can use just by multiplying by a common denominator, and then they will all vanish if we do it correctly. So we have to ask ourselves, what's a common denominator of 6, 8, and 4? Well, 6, 8, and 4 have one in common. I believe it's 24. So let's go ahead and take each side and multiply by 24. So the left-hand side of the equation, 6 goes into 24 4 times. So we have 4, and then we still have to multiply by the x plus 3. And then on the right-hand side of the equation, remember this 24 needs to get distributed. So 8 goes into 24 3 times, so we have 3 times 3. And then 4 goes into 24 6 times, so we have 6 times x minus 5. And then we're just left with an equation like we had in the previous example. So we'll get 4x plus 12 equals 9 plus 6x minus 30. We can do a little combining on the right-hand side of the equation and get 6x minus 21. And then move our x's to one side. So we have 12 equals 2x minus 21. And then get a little more room, and then we can add 21. So we have 33 equals 2x. Divide by 2. X is 33 over 2. That is your answer. Or if you want it in decimal form, you can turn that into 16.5. Okay, same thing applies with these rational equations. We still want to multiply by something that's going to clear all those denominators out. But, what did I want to say? Oh, so your answer, wherever you get to, has to make sense in the end. So in this original equation, just observe that x equals 0 is not a possible solution. So even if somehow we end up with it, it would still be no solution, because that would cause division by 0 in our original problem, which is what our answer needs to work in. So this 4 over x equals 5 over 2x plus 3. Basically, we want to take all that and multiply by 2x. And if you do that, you'll clear all the denominators out. So on the left-hand side, the x's cancel, and we just get 4 times 2, which is 8. And on the right, we have to remember to distribute. So to the 3, and then also to the 5 plus 2x, 5 over 2x. 2x times 5 over 2x just leaves us with 5. And the last term, we just get 3 times 2x. So we get 8 equals 5 plus 6x, subtract 5. So we get 3 equals 6x, or when we divide by 6, we'll see that that just makes x 1/2. So that's our answer. So even with rational functions, we can still clear the denominators to make our solution technique easy. We just have to remember not to allow these solutions that might cause 0. Alright, so let's try another one. This one, pretty simple. We just multiply by x plus 1 on both sides. So on the left, we just get 8x. On the right, we have to distribute, so we'll have 4 times x plus 1. And in the second term, we get cancellation, so it just becomes minus 8. Then we get a nice linear equation, 8x equals 4x plus 4 minus 8. So we have 8x equals 4x minus 4. Subtract 4x. So this will simplify to 4x equals negative 4. Divide by 4, that leaves us with x equals minus 1. Okay, these next few problems talk about a inconsistent. All the equations we've looked at so far have been conditional equations, because we just have one solution. That's the terminology. And identity is something where you end up with an obviously true statement where all real numbers work. An inconsistent equation is something where you end up with a false statement. So if you actually turn your eyes to the solved problem, let's look at the inconsistent. So they basically multiply out. We have some equation that looks like it might be true, but at the end of the day, they try and solve it, and they end up with negative 7 equals negative 1. which is clearly false. Those are two different numbers, so they can't be equal. So we say the solution set is empty. That's an example of an inconsistent equation. This example right here is going to give us an identity. So let's try and solve the normal way. 5x plus 9. Distribute on the right. 9x plus 9 minus 4x. So 5x plus 9. And when we combine on the right, we get 5x plus 9. So these two things are the same. Basically, notice any number you plug in for x, you're going to get the same answer on both sides. So this will always hold true for any value of x. So that's why this is called an identity. You can go one step further if you really want and subtract 5x, but then you just get 9 equals 9, which again is always true no matter what number you plug in. So we say this is an identity, and the solution set is all real numbers. Or sometimes they use this fancy R. Okay, let's keep going. We have one more. Is it conditional, inconsistent, or an identity? Well, you can subtract 8x to start. And then you get 2x plus 3 equals 3. Subtract 3. So we get 2x equals 0. Divide by 2. 0 over 2 is just equal to 0. So x equals 0. So this is a conditional equation because it has just one answer. Okay, now we got a few word problems to deal with. So let's look at this one. The formula C equals 1388x plus 24963 can be used to model a cost X years after 1980 of what something costs $10,000 in 1967. So we want to use the model to determine which year the cost will be $77,707 for what cost $10,000 in 1967. So in some sense, this is just modeling the inflation of an object that was $10,000 in 67. So what are they giving you? They're giving you a cost. We just need to solve for x. So you do 70,707 equals 1388x plus 24963. Get the x's on the one side by themselves. So on the right we have 1388x. And on the left, we'll probably get something divisible by that number. I don't know what it is. So let's see if we can get a calculator program somewhere in our lives. So we have 77,707 minus 24963. That gives us 52,000. What was the rest of the number? 744. Now we just divide both sides by this 1388. And we'll get x as some number, so let's just punch that in over here. My instincts tells me that it should I'm gonna guess it's 38 if I do that in my head. Let's check my mental math though. Divided by 1388. Yep, 38, so I did it in my head correctly. Alright, so what does that mean? Well, that means the item that costs 10,000 and I believe it was 1967 costs 77,707. 77,707. 38 years after 1980. So in 2018. Remember, that's 1980 plus 38. That's in the problem it told us right here, X years after 1980. Okay, that's 1.2. One more section left. This one's just one problem, but it's a bunch of different kind of word problems, which everyone loves, I know, but I think they're kind of fun. So really the thing is, you kind of want to deconstruct these problems. I like to go a little bit out of order, because the last sentence normally gives you what you're looking for or what you want to set your variable to. So it says, over your lifetime, how many years will you spend on each of these activities? In this case, number of years sleeping and number of years watching TV. So let's let S be years sleeping, and then T years watching TV. So basically then you want to go back over the problem and read each sentence and see if you can make an equation. So first sentence says you'll devote 37 years to sleeping and watching TV. Well, that's cool. That tells me that S plus T equals 37. Then it says the number of years sleeping will exceed the number of years watching TV by 19. Well, that also tells me an equation. So if the number of years sleeping exceeds TV, that means sleeping's bigger. So sleeping has to equal T plus 19. Right? So sleeping is now exceeding TV by 19 years. So we can use these two things to write a single linear equation. So we can take the first equation, and where we had S, plug in T plus 19. So we'll have T plus 19 plus T equals 37. What I did was I plugged this value in right here. And now there's nothing to distribute, so I don't really need the parentheses, so this just becomes 2T plus 19 equals 37. Subtract 19 from both sides. That will leave me with 18. Yeah, 18. So then that tells me that T equals 9. And if T is equal to 9, sleeping must be equal to 9 plus 19. So we know that that makes, so S has to equal 9 plus 19, which is 28. So you spend 9 years watching TV and 28 years sleeping. 1B, 2 health clubs. Club A offers membership fee for $40 plus a monthly fee of $25. B offers $15 plus a monthly fee of $30. How many months will the total health cost at each club be the same? So let's write out the cost of A. The cost of A is given by the monthly fee plus the Club A has membership for $40 and monthly fee of $25. So 40 plus 25N, where we'll say N is the months belonged. And then Club B, how much does it cost? Well, it's got a $15 startup, cheaper startup, but it's got a $30 monthly fee. And then the last sentence, after how many months will they be the same? Well, we just set them equal to each other then, and solve. So if you subtract 25N from both sides, you'll have 40 left on the left and just 5N left on the right. Then subtract 15, you'll get 25 equals 5N. And then divide by 5, and we'll see that N is equal to 5. So 5 months, the memberships at A and B will be the same. After that, B is going to become more expensive. So if you plan on working out for more than 5 months, you want to join A, because in the long run it should be cheaper. Okay, last one I think. So we have two accounts that earn different interest rates. So the question is asking you how much was invested at each rate. So let's let X be amount invested at 6%, And we'll call y the amount invested at 8%. And let's try to read the sentences to see if we can get some good equations. So it first says you invest $7,000 total in two accounts paying 6% and 8%. Okay, so that means x plus y has to equal 7,000, because x is the amount invested in one, y is the amount invested in the other, and x plus y is the total investment. Next sentence, if total interest earned is $520, how can we figure that out? Well, the interest earned from the x account should be 0.06 times x, 6% of x. And the amount earned in the y account should be 0.08y, because it earns 8% interest. And that equals your total 520. So we just want to substitute something from the first equation into the second equation. So we can replace x with 7,000 minus y if we move the y to the other side. So I'm basically going to take this and I'm going to stick it in here. So I've got 0.06 times 7,000 minus y plus 0.08y, and that equals 520. All right. So 0.06 times 7,000 should be 420 minus 0.06y plus 0.08y. That equals 520. So 420 minus plus 0.02y. That equals 520. So subtract 420 on each side. So 0.02y equals 100. So if you 100, not 1,000. So if you divide by 0.02, I believe that's going to give us 5,000. Yeah, so that will give, yep, it'll give 5,000. Okay, so if we have 5,000 in account Y, remember x plus y has to be 7,000, so we have 2,000 in account X. 7,000 in the 8%, or 5,000 8%, 2,000 in the 6%. Oh no, there are a couple more, I lied. So solve for each variable is the last thing. So basically what you want to do is just get the number by itself. So this term has a p, get it by itself. T minus d equals pm. And then divide by the number that's not p. So divide by m in this case. So that's our formula for p. T minus d over m. And then we can do the same thing in the next one. It's really not that tricky. But the first thing to notice is both terms actually have an I, which is the variable of interest. So we want to factor that I out first. So then we get capital R plus little r. That equals capital E. And we just divide by that number. R plus R. R plus R. So I is given by the formula E over R plus R. Okay, that's it for this module's lecture, and I will talk to you again in a week or so.